Hello, welcome regular viewers to this virtual learning, Omega virtual learning, and I also welcome new viewers to this channel. Hope you find it very educative. This is Bounds 2, where we talk about calculation involving bounds. If you haven't watched lesson 1 on bounds, please pause this video and maybe go back and watch that, because most of the rules that we'll be using here were discussed in lesson 1. How do we add two numbers using bounds? Okay, line A and B are measured in centimeters. Line A measured 12 cm and line B 10 cm. All measurements correct to nearest centimeter. Calculate the lower bound and the upper bounds of the total lengths of A and B. So here we are supposed to add. Now this is what you need to remember. When adding two numbers, to get the biggest possible answer, you take the upper boundary of each measure. And if you want to get the lower bound, you take the lower boundary of each measure to add. As simple as that. So the clue here is nearest cm, nearest 1 centimeter. So 1 divided by 2, that's the rule you're going to use. That's why I said if you haven't watched lesson 1, please go back to watch it. So it's plus or minus 0.5. So the lower bound will be 11.5 plus 9.5. So we're going to take the lower bound of each measure, that's 21, and upper bound, take the upper bound of each measure, 23. So we're going to, this is what we use to create the lower and upper bound. To get the upper bound, we add 0.5 to each numbers. To get the lower bound, we take out 0.5 from each of the numbers. Multiplication, they work the same way as the addition. You take the biggest of each for the maximum number, and you take the smallest of each for the smallest product. So here we have a rectangle with dimension 3.2 meters, 5.9 meters, all correct to 1 decimal place, and want to see the smallest possible area and the largest possible area. So the clue here is 1 decimal place, which is 0.1 divided by 2. So our rule will be plus or minus 0.05. So we're going to use this rule. Let's start with the lower one. Lower bound, we take 0.05 from each measure to get a lower bound. So that's what you will have, 18.4275 meters squared. For the upper bound, we add 0.05 to each measure to create the upper boundary, and we multiply, and that will give us 19.3375 meters squared. So it's just knowing your rule and knowing exactly what you are doing, and that's it. Subtraction, they work opposite ways, so you got to be careful with subtraction. So here, a piece of metal 2 cm long is cut from 100 cm. So simply 100 minus 32. That is exactly what the question is about. But we're going to work it in bounds. Both measurements are correct to nearest cm. Find the upper bound and lower bound. So 100 minus 32 is the original question. What will be the lower bound? What will be the upper bound? For subtraction, you take the bigger number, upper bound of the bigger number, minus the lower bound of the smaller number to get the upper bound. To get the lower bound, you take the lower bound of the bigger number and you subtract the bigger bound of the smaller number. So let's see. Our rule is 1 divided by 2, so plus or minus 0.5 because nearest 1 centimeter. So we start. 100 lies between 99.5 and 100.5 cm. So 99.5 is the lower and 100.5 is the upper. Our 32 will be between 31.5 and 32.5, lower boundary, upper boundary. So to get the lower boundary, we're going to take the lower boundary of the bigger number and minus the upper boundary of the smaller number. So you get 67 cm. To get the upper boundary, you're going to take the upper boundary of the bigger number and subtract the lower boundary of the smaller number. So it's 69 centimeters. You need to just remember the rule, and you are just doing addition, subtraction, multiplication, division. That's all you are doing, but you need to know which numbers to choose. So study these rules carefully. Let's look at this exam style question. A car runs 240 kilometers in 2 hours. The distance is measured to the nearest kilometer, and the time is measured to 0.1 hours. Calculate the upper bound and lower bound of the average speed. So you must first know the formula for average speed. You know, speed is distance divided by time. Distance divided by time. Now let's check the rules. Nearest kilometer means nearest 1 unit. Nearest kilometer. So it's 1 divided by 2. So it's plus or minus 0.5 for the distance. So you know 240 kilometers will lie between 239.5 and 240.5 kilometers. So this is the lower bound of the distance, upper bound of the distance. Nearest 0.1 hours. So you divide it by 2, so plus or minus 0.15. So let's create the upper and lower bounds for the time. So 2 hours is 1.95 and 2.05. Lower bound of the 2 hours time, upper bound of the 2 hours time. And we know it's distance divided by time. If you want to know the lower bound, it's similar to the subtraction. You take the biggest number of the numerator and divide by the lowest number of the denominator. That's for the biggest answer. For the lower bound, you take the lower bound of the numerator and divide by the biggest number of the denominator. So here, you just pick the numbers the way you've done it. So the smallest of the numerator divided by the biggest of the denominator. That's what we'll have, kilometer per hour. Upper bound, we take the biggest of the numerator divided by the smallest of the numerator. So that's 123.33 kilometers per hour. So it is all a test of knowing which choice of numbers to use in your calculation. Significant figure question. Find the upper bound and lower bound for the area of a circle with a radius 2 cm, correct one significant figure. Now, what I need students to understand here is that in doing boundaries, only actual measurement should be changed using bounds. If a number is a constant, you don't create bounds for it. You only create bounds for measured numbers. So here, we're supposed to work out area of a circle. Now, area of a circle is pi r squared, and it's only the radius that is measured. So it's only the radius that we will apply the bounds rule. So 1 SF, the 1 divided by 2 gives us the rule plus or minus 0.5, because it says that it's correct to one significant figure. 2 is so the first significant figure, which is a unit. That's why we have plus or minus 0.5. If you don't understand the rule of significant figure, please go back to lesson 1. So for the lower bound, radius is 1.5 as lower and 2.5 as the higher. And formula is pi r squared. Multiplication rule. So we're going to use the biggest for the bigger number and lowest for the lower number. So if you want the lower bound area, you're going to use the lower radius. And that will give us 9/4 pi cm squared. If you want the upper, you're going to use the upper measurement for the radius, which is 2.5. That will give us 25/4 pi cm squared. You are allowed to use calculator to get the actual decimal. So, but this is the answers in terms of pi. So know the difference when to use the biggest number and when to use the smallest number. Now, this is a typical exam style question we call it degree of accuracy. That students get confused about. Just to sum up, for this question, you have to work out both the lower boundary and the upper boundary and line up your answer and see at what point an approximation will give you the same value. So let's see what we do here. Pause the video and read the question. Okay, now let's move in. If you finish reading the question. So here, we are supposed to work out the consumption. And the consumption formula is D over F, where D is the distance and F is the fuel. Now, each measurement is correct to say 3 significant figures, but they are different values. So you start 3SF rule for D. 3 is unit, so it's 1 divided by 2. So that's our rule. So we're going to get a distance to lie between 162.5, 163.5. 3SF rule for F. This is decimal 0.1. The place value of 3 is 0.1. So 0.1 divided by 2 will give us this rule. So our lower bound will be 45.25 and 45.35. Now division rule. If we recall division rule, numerator should be the biggest possible and denominator should be the smallest possible to get the biggest answer. For a smaller answer, numerator should be the smallest possible of the numerator and the denominator should be the biggest possible of the denominator. So recall your division rule. In case you've forgotten, let me take you back to division rule. So this is the division rule. So in case you've forgotten the division rule, to get the biggest of the numerator divided by the smallest of the denominator. To get the lower bound, the smallest of the numerator divided by the biggest of the denominator. So let's start with the lower bound. So we take the smallest of the numerator. Smallest of the numerator is this, divided by the biggest of the denominator. So that's what you have. Let's do the upper bound. We take the biggest of the numerator divided by the smallest of the denominator. Now you realize that at what point when we approximate we will get the same answer. If you check, 3 is the same as 3. Okay, 3.5, 3.6, they are not the same. 3.58, 3.61, they are not the same. But if you round to one decimal place, you will get 3.6 here, and here too will round to what, 3.6. So which means our true accurate answer is 3.6, rounded to 2 significant figures or one decimal place. So when a question is given to you and say work out to a suitable degree of accuracy, all they want you to do is to do both calculation for lower bound and the upper bound, line your answer up, keep on approximating and see at what point when you approximate you will get the same answer. And you have to state whether you are approximating to a decimal place or significant figure. And that's all. And that brings us to the end of lesson 2. Hope you've enjoyed the lesson. Please share with your friends and thanks for watching.